Welcome to the Charleville Severe Weather Analysis for Friday, November 21st, 2025. This morning's atmospheric sounding, taken at 10 a.m. local time, reveals a moderately unstable environment with the potential for afternoon thunderstorm development across the region. Looking at this morning's skew-t diagram, we can see the red temperature line and green dew point line showing our current atmospheric profile. The gap between these lines tells us about moisture availability. At the surface, we are starting with temperatures around 32 degrees Celsius and a dew point of 17 degrees. The blue shaded area represents CAPE, or convective available potential energy, which is the fuel available for thunderstorms. This morning, we have 512 joules per kilogram of mixed layer CAPE, which is marginal energy for storm development. The lifting condensation level, marked on the plot, sits at 1900 meters above ground, which is moderately elevated. The atmosphere shows minimal capping, meaning there's very little lid holding back storm development. Wind speeds are light near the surface but increase with height, creating about 15 meters per second of deep layer shear through the first 6 kilometers. Now let's examine what happens as we heat through the day. The enhanced skew-t shows multiple parcel paths. With forecast maximum temperatures reaching 40 degrees Celsius, the afternoon heating will dramatically transform this environment. Notice how the pink CAPE area expands significantly. The heated mixed layer parcel, shown by the orange line, reveals that afternoon CAPE will surge to 1905 joules per kilogram, nearly quadrupling from morning values. This is a substantial increase in atmospheric instability. The lifted index drops to minus 4.7 degrees, indicating strong instability. With deep layer shear remaining around 15 meters per second, we have the ingredients for organized multicellular storms, and possibly even weak supercells if storms can initiate. The combination gives us a Craven discriminant value of 173,000. Well above the threshold for severe weather potential. However, storm initiation remains the key question. The atmosphere is favorable, but triggering mechanisms like convergence boundaries or surface heating gradients will determine whether these ingredients get utilized. Looking ahead to tomorrow morning, the GraphCast machine learning model forecasts a dramatically different atmosphere. The forecast shows 0 joules per kilogram of CAPE, indicating a stable, subconvective environment. This represents a complete collapse of atmospheric instability compared to today. The dew point profile shows extremely dry air, with the lifting condensation level forecast at 3065 meters above ground, which is very elevated. Deep layer shear remains moderate at 16 meters per second, but without any CAPE, this shear cannot support thunderstorm development. The supercell composite parameter and significant tornado parameter both drop to 0. Storm mode is classified as subconvective, meaning insufficient energy exists for sustained convection. Any shower activity would be weak and disorganized. This dry, stable pattern represents a significant change from today's potentially active conditions. The hodograph provides crucial information about wind structure through the atmosphere. Each point on this spiral represents wind at different heights, with colors transitioning from dark blue near the surface through green and yellow at mid-levels. The low-level winds are weak and somewhat backed, shown by the dark blue portion near the center. As we climb through the atmosphere, winds veer and strengthen, creating the curved path. The red star marks the bunker's right-moving supercell motion, while the blue star shows left-moving storm motion. Deep layer shear of 15 meters per second is present, which is moderate but not exceptional. The 0 to 1 kilometer storm relative helicity measures 101 meters squared per second squared, which is marginal for rotating updrafts. The 0 to 3 kilometer helicity reaches 247 meters squared per second squared, providing some support for storm organization. The hodograph shows relatively straight wind profiles through much of the atmosphere, which favors multicellular storm modes rather than discrete supercells. This wind structure, combined with today's afternoon CAPE values, creates conditions favorable for organized storms with marginal severe potential. In summary, this afternoon presents marginal to slight severe weather potential for the Charleville area, with small hail and strong wind gusts possible if storms develop. The key limiting factor is storm initiation in the dry boundary layer. Tomorrow brings a return to stable conditions with minimal thunderstorm threat. Always consult the Bureau of Meteorology for official warnings and forecasts, and never rely solely on atmospheric soundings for severe weather decisions. Stay weather aware, and have a safe day.